Here's some help with your last homework assignment. So for number 74, what you want to do is you need to expand the natural logarithm of the cubed root of x cubed over y squared. So one thing to remember is that the natural logarithm is just the normal log with base e. So one thing that's important to know is how to write a cubed root using a fractional exponent. So just like we did in class, when you have a square root, the power is 1/2. With the cubed root, the power is 1/3. So we'll just replace the cubed root with a power of 1/3. And then you can take that power and you can just expand it to the top and the bottom of your fraction. So that's the same as log base e of x to the 3 to the 1/3 over y squared to the power of 1/3. And now you can combine your exponents using your exponent laws. And just multiply your exponents together. And you'll get x to the 3 times 1/3 and y to the 2 times 1/3. Which is the same as x to the 3/3, which is just x, and y to the 2/3. And now you can try to use your laws for when you're dividing two things inside of a logarithm and your exponent law. So you should keep going until x and y are separated into two separate logs. I'll let you try that at home, and if you get stuck, you can keep asking questions on Piazza. So now in questions 86 to 96, there's basically two types of questions. So the first type of question is exponential equations. And that would be questions 86, 88, 90, and so on and so forth. So for this first type, we want to solve for x, so we want to get x by itself. So take an example like 86. We're given 2 times e to the x plus 1 is equal to 7. So we want to get the x by itself, but it's stuck up in the exponent. So the first thing you want to do is get all the numbers to one side. Until you have something of the form number to the power of something equals another number. Okay, so you just want some exponent on one side equal to another number. So what we're going to do is we're going to take that 2 and move it to the left side of the equation. Since it's multiplication, we'll divide it on both sides. So we get e to the x plus 1 is equal to 7/2, or 3.5. And once you're in the form, so now I've got it in the form of something to the power of something is equal to a number. So now what I can do is I can change from exponential to log form. Okay, so you're going to use this technique anytime you have a variable in the exponent. To take this base to the other side, it becomes the base of a logarithm. So changing it to log form is the same as taking the base of the exponent on one side and making it the base of a logarithm on the other side. And now I can simply solve for x. By putting 1 on the other side. And I get x is log base e of 3.5 minus 1. So that's the same thing as doing natural logarithm of 3.5. Log base e is the same as natural logarithm. So if I want to put that into the calculator, I would just go natural logarithm of 3.5 and then subtract 1. And that would give me an approximate value for x. It's about 0.25. Now, the second type of equation is your logarithm question. We did some examples like this in class. This would be like numbers 90, 92, all the way to the end. So let's take number 92 as an example. So here your goal is to have one logarithm on each side of the equation with the same base, and once you get it down to one log on each side, then you can cancel off your logs, and whatever is inside will be equal on both sides of the equation. So we've got 2 log base 3 of 4x equals 15. In order to solve this, what we can do is divide both sides by 2. And we get log base 3 of 4x equals 7.5. 15 divided by 2 should be 7.5. Okay, so now it's kind of hard to make it in the one log on each side of the equation. It's kind of hard to write 7.5 in terms of log 3. So we'll do the same thing that we did before. We'll change from log form to exponential form. Okay, so anytime that you have a log on one side of the equation, because logs and exponentials are inverses, that log can become an exponential on the other side. So the same base for the exponent will be the base on the other side of the equation. So 3 to the 7.5 equals 4x. And 3 to the power of 7.5 is just a number. That's about 3,788. Okay, now I can just divide both sides by 4. And I'll have my value for x. It's approximately 947. Okay, so you don't usually change from log form to exponential form when you're solving a log equation. So maybe I'll take one of these odd ones just as an example so that you can kind of know the typical steps for solving a log equation. So if you look at number 95, this one isn't in your homework, but it can help you understand. Ln x minus ln 3 equals 2. Okay, so I can just show you how to do this using the method where you're trying to make one log on each side. Now remember, ln just means log base e. So anytime you see natural log, you can replace that with log base e. Okay, we're going to use the log laws to try to combine all the logs and to make it as compressed and compact as possible. So when you have two separate logs being subtracted, you can write that as division inside of one logarithm. So we use your log laws to compress your equations. So we're going to write this as one logarithm where x and 3 are being divided. And you can write any numbers in your equation. As a logarithm. So if you want to create the same base everywhere, we can take the number 2 and we can write that as log base e of something. So we need to figure out, what would I take the logarithm of so that the answer would be 2? Well, remember, a logarithm just means e to the power of what number is equal to whatever's inside the logarithm. So in this case, if we take e squared, then e to the power of 2 would be equal to e squared. So if we put e squared here, log base e of e squared is 2. And we could check that. ln of e squared is 2. Okay, and this is great because now I have one logarithm on each side. They're the same base, so that means the inside of the logarithm has to be the same. So x over 3 is equal to e squared. And now I can just multiply both sides by 3. And I get x is equal to 3e squared. So x is approximately 22. And you should always check your answers to a logarithm to make sure that it doesn't provide you with an extraneous solution. Make sure it's defined. So the original question was ln x minus ln 3 equals 2. Okay, so when we put the number 22 in here, ln of 22 is 3.09. So that's okay. We didn't get a non-real answer. Okay, so that means that this really is an answer. We should check the other ones above too. Okay, is 390 or 347 okay? When we put 347 in here, then it becomes log of 4 times 347. So log of 3 times 437 is 3. Oops, I chose the wrong numbers. Okay, so that's defined. It's real. We're okay. We don't have to worry about a non-real answer. Okay, so if you get stuck, just keep asking questions on Piazza, and I'll help you out here.